Cody Kinsey is an ethical hacker. He's teaching in beginner level for all about open source, intelligent, Wi-Fi, and electronic security. He's also the host of various YouTube channels, Hack5, Nullbyte, and RITEA. And he's also organizing security trainings and talks. For example, like this awesome talk here. Meshtastic is an off-grid encrypted mesh network which can be spanned over 100 miles. It's open source and affordable. So if you want to have a low-cost solution for only starting at $5 or $10, well, this is going to be your shot. This will be a beginner's guide to Meshtastic, starting from the hardware basics to some advanced software configurations, with some real-world results from Meshtastic in Los Angeles. Let's go and have fun.
Hello, everyone. Wow, this is a really big room. All right, so I am here to talk about something I'm very excited about. I have like 60 slides in 45 minutes, so I talk very fast, and this is recorded. If I talk too fast, maybe it's better that you watch it a little slower and I get more information in. I'll try to strike a balance, but anyway, we're going to do what we can. So what are we going to talk about today? We're going to talk about different types of LoRa and Meshtastic hardware, both custom and the kind that you would just buy on like AliExpress or Amazon. We're going to talk about legal and practical considerations. We're going to talk about LoRa and mesh networking fundamentals, how to set up new nodes for specific use cases, and also how to join mesh networks in your own community. We're also going to talk a little bit about Meshtastic security and privacy considerations, because when I started getting into this, I was quite surprised to see that the encrypted messenger was actually a little bit more complicated and required some setup to really protect your messages if you want them to be private. So why should you listen to me? Well, if you ask ChatGPT who I am, then it's actually pretty accurate, except for the fact that it thinks I have had a secret career in the Air Force that I don't recall. Aside from that, you can find what I do on there. I'm a security researcher who is obsessed with Wi-Fi and OSINT. It's kind of where I got into ethical hacking, but I've expanded into electronics, and naturally, kind of the bridge of all those things is LoRa, this long-range protocol that's low cost, low power, and extremely long range. It's what I've been waiting for years. So I make videos on the Nullbyte and RITEA security channel. The RITEA team also comes with me to these conferences, and we've been putting on workshops non-stop in the hardware hacking area. We have our assembly, ScriptKitty assembly, that has become part of the hardware hacking area. So hopefully you'll come and check out some of our other workshops. We have 3 more for the rest of the conference, 2 of them being Meshtastic. Oh, and also, if you like what we do, we are also currently looking for sponsors. All right, so what is the point of Meshtastic? So it is bidirectional, off-grid encrypted communication over very long distances in a single sentence. That's why it's cool. It's amplified by nearby nodes. So regional networks can span over 200 miles. I've actually seen this. And you can include motion sensors. You can track objects. You can control objects from afar, which obviously might be problematic in some certain contexts. And then it provides very robust communication in areas that are super congested. So in areas that normally would have too much radio noise to operate. This ultra low-cost hardware also makes it accessible for anybody who might toast a node or 2 during their experiments. I become interested in microcontrollers when they reach about $5 on AliExpress. And this year, the first LoRa radio that's super popular for Meshtastic hit less than $5. So I instantly had to get in on this and learn as much as I could about it. So what's the cost of participating? If you want to go home and you want to make this monstrosity, you absolutely can, and it costs about $5 to make. That's really cool. I was able to source these. The RP2040 breakout here costs about $1.20 or so, and then the LoRa board costs $3 something on AliExpress when you buy them in bulk. So you can make these cheap little nodes. They're ugly, they crash sometimes, but they can get up to 250 kilometers of range line of sight. So that was from an airplane, but it's still worth noting that they have incredible range when they're on an elevated position or they're able to get a clear line of sight. So with other nodes, I would say 1.5 miles, a couple miles is much more typical from what I've seen in the Los Angeles area, but these are heavily radio congested areas with lots of buildings and such, which kind of limit that. So for a very fancy node, like something like this from China, you can get one for about $80. I recently dropped one of these off of my car and it got ran over by a truck, but aside from that, it survived everything I've thrown at it so far. So what can we make with this? Well, off-grid chatting devices in remote areas. So imagine you're at a concert, you're at a rave, you are underground or something like that, and you want to be able to communicate with your friends. There's no cell signal. Maybe you're in the backwoods and you're hiking or camping or something. Maybe it's at an event. We recently went to Tour Camp and we set up Meshtastic nodes and we were able to talk to our people when we were in the San Juan Islands. So these are very useful for off-grid communication in general, and safety is one of them. I've already talked to some people today who are doing events and they want to be able to communicate with organizers or do other things that are integrated into people's phones and are seamless. It's very easy to use. And because a lot of these use Bluetooth, it means you just get notifications and it kind of acts like this router in your back pocket, kind of routing packets around the mesh net. So it also can do inter-vehicle communication. So let's say that you are communicating between a convoy of vehicles. It can also do encrypted disaster and emergency response, and it has military applications in kind of sharing map intelligence. So the reason military people are interested is they can find things, like they can scout things, identify them, and then sync map objects to all sorts of people who are wearing these distributed mesh nodes. And they're very low power, they're kind of hard to track. So the military thinks they're super cool for sharing maps and like intelligence on the battlefield. So there's also remote sensor telemetry for environmental and presence sensing, and this is really what Meshtastic is excellent at doing. A lot of people like to build telemetry and sensor nodes with them, GPS tracking of moving nodes, of course, and then remote control of hardware. So one of our friends, Davis DeWitt, a former Mythbuster, put together a little LoRa-controlled car that you can come by and hopefully see at our booth tomorrow. So let's define some terms before we get too far into this, because I don't want people to get confused. LoRa stands for long range, and it is an unlicensed radio spectrum protocol that allows you to send messages in these up chirps and down chirps. And if you look at the Meshtastic logo, you might notice it's made out of up chirps and down chirps. So if you didn't know, now you do. So these up chirps and down chirps are very resistant to jamming, and they are easy to be received even significantly under the noise floor. So LoRa is the underpinning technology of most of what we're talking about today. So running on top of that is Meshtastic. So this is a protocol that runs on top of LoRa, and if you're interested, it runs at layer 3 of the OSI model. All right, so where does all this spring from? Well, recently these chips have come out that allow you to modulate these signals, and the actual radio chips look like this. This is kind of the latest and greatest, one of the ones that is best supported by Meshtastic. It's the SX1262, and it just looks like this little teeny tiny chip. It's not very useful on its own. It's not broken out, and the average person really can't do much with it. Next up, we have the host microcontroller. This is the little computer that's running Meshtastic, that's controlling the radio, and the radio is sending the signals, but the host microcontroller is what actually runs the show. This also is just a tiny little square, but these tiny little squares can do a lot when they're put onto a breakout board. So breakout boards are how you make these tiny little, very cheap but very capable modules accessible to hackers, makers, and anybody who wants to make a product. You add pins, you add power, you add all this management stuff that makes it so you can actually use these things. And these modules have hit such a low cost in so many places that it means you can build these nodes for incredibly cheap, and all you have to do is basically stick them together. You don't need to design a custom circuit board in some cases if you want to airwire it, as I did that one time, but you probably should if you want to do a good job. So what is a node? Well, a node is basically just a radio plus a host. So when you put those two things together, you've got the microcontroller, you've got the radio, you get a node. And a node is capable of running Meshtastic. We have a simple node on one side, this is the Heltec wireless stick, and we have a more complicated, durable but not run-overable node on the other side, the Lily T Echo, which are two of the usual suspects I see people go to. Now, anytime we have a host and a radio, we can create a node, provided it's supported by Meshtastic. So that's kind of the general math here, is like in order to create a Meshtastic node, we need the radio, we need the host microcontroller, and there's a number of different microcontrollers that can all run Meshtastic. There's also a number of radios that are supported by Meshtastic. So that's really cool, because it means we can have kind of a grab bag of technology and make interesting and useful long-range nodes out of them. Future nodes are getting even more integrated. So right now, I have our own little custom node that we made for the conference, and it uses these two microcontrollers here, the ESP32S30 and the RFM95. Now, the node that's on the tip of my finger has both of them underneath one little can. And obviously, it doesn't have like a USB, so it would need to be put on a breakout board. But this is basically a ready-to-go Meshtastic node, all on the tip of my finger for about $7 right now. So that's pretty incredible. This is becoming more and more integrated. It's getting cheaper. So if your brain is already kicking for things you could do with a fully integrated node like this, that you just put on a little circuit board, add maybe a USB or power management, and you're ready to go. That's pretty incredible. So that's why I'm excited about this and why I think people should know. So one thing that my team has been working on is designing our own hardware. So I wanted to shout out the process of creating Meshtastic hardware was a little bit more difficult than we thought, but it was also super rewarding because as we started using Meshtastic, we started building things that allowed us to do all the really interesting stuff that you might have heard about, sensor telemetry, remote control, all those things we started building out into backpacks and we made it so that anybody who wants to start working with Meshtastic and like try out some of these modules with hardware or just prototype with Meshtastic would have a really good time. This particular design has a Bluetooth, Wi-Fi, native USB, and serial, so there's a lot of ways you can use it. Quick connectors for I2C sensors, 6 buttons for sending and receiving canned messages, 2 neopixels for status indicators, an OLED display, and then Bluetooth, Wi-Fi, and support for I2C. This was kind of our baby, and we added a lot of stuff to this backpack. By the way, it's a cat butt. Can you see it? Cool. So, So we wanted to make this really fun for people, and we brought like a couple hundred of them. So if you're interested in these, we have a story to tell about this, but I will save that for the rest of the talk. So the second device we set out to create is the Nibble, and this is something that I created after using the Heltec wireless stick as a router. And there is a soccer score sign in my city where I live that has a power outlet that has been powering this little router in the middle of a field for several months now. And it inspired me to make a really simple node that's like your first Meshtastic node that you can expand as much as you want, but is simple enough that you can put together. And I decided to create the Nibble. So I have an artist friend, Felix, who is responsible both for the cat butt and also for the faces here that led to the Nibble. So I have to shout them out as being an incredible asset. Working with artists, if you do technology, is really essential. And they created kind of the look and feel after I decided to create something that could fit in a PVC pipe, get hoisted up on a USB stick, and then either be accessed via serial or just connect to your Wi-Fi network and route packets with Meshtastic. So we created it, and we brought 300 of them here, and we've already done one workshop with them. So if you're interested in making these, we're going to be soldering them together actually immediately after this talk. So when I designed this, I actually made pads for 2 different microcontrollers. I made it so you could add an RP2040 if you're a fan of the Raspberry Pi, and an ESP32S3 if you want all the bells and whistles. And I kind of thought, oh, like you guys can make like one or the other. We'll make one cheaper, and you can still do that if you want. The reason why I've kind of decided to just use the ESP32S3 is because iOS doesn't support serial connections, so you can't just plug it in and use it in your iOS device. And I really want everybody to be able to use it right away. So because the ESP32S3 supports Bluetooth, I decided to use that as the host controller. But it actually can take both as a kit. So if you end up picking up a kit and you really want to make an RP2040 Nibble instead, it is actually built for that. So the other thing that's cool, and this is about Meshtastic as well, is you can just solder on I2C sensors, and there's a long list of supported sensors that you can work with. So we designed this to make it so that you could just solder. In this case, this is an environmental sensor, temperature, humidity, and pressure, barometric pressure. Yeah, I think that's it. And it transmits every 30 seconds over the net, and other nodes record it and report it. So this was really cool. If you want to join us afterwards, then I hope to see some of you downstairs in the hardware hacking area. But now let's talk about LoRa. So this is not for webcam monitoring. It is very, very slow. So I'll show you data rates later, but just trust me when I say this is good for control signals, it's good for telemetry, and it's good for messaging. It's not really good for anything crazy. The reason why it's special is because it uses these up chirps and down chirps to defeat all these other problems we have with recognizing below the noise floor. You can dig into this a little bit more because it's probably one of the more fascinating parts of Meshtastic and LoRa, but it can decode packets 20 dB below the noise floor, and it has an effective sensitivity of negative 149 dBm. So that is pretty crazy to me, and it means that it can really deal with some punishing interference and still manage to be received. Now, chirps are kind of unique because they are a way of transmitting data that has been very successful. You can spread them across the spectrum, and this is some more information if you want to kind of dig into how LoRa is able to like widen and shorten and add error correction and make it much more resistant to jamming. Basically, the trade-off is this: the more range you want, the slower the data rate will be. The faster the data rate, the shorter the range will be. And that is just essentially the trade-off you will always make with LoRa as a technology. So what are some common types of LoRa radios you can buy today? So the SX1276 is the one that is in our Nibble and also our backpack. It is tried and true. It is very well supported, and it is part of the older generation, but it works very well. The newer generation is the SX1262. This is, if you can find them, software selectable. So I wouldn't have had to bring two completely different types of radios, one for Europe and one for the US. These newer ones are actually, again, software selectable, so I could have just brought the same one and just told it in software that I want to use it in the EU. My bad, but now I know. So that brings me into regional frequencies. Had I not known this, I would have brought you all a bunch of radios that are illegal to operate in Europe, and that would have been fun and exciting for you all to explain. So fortunately, this regional map explains very well where you can and can't use certain frequencies. And this does not include another frequency range that's legal in the EU, but I'm not really covering it too much because it doesn't seem very popular and it doesn't seem to get as good reception as 868. So if you're buying any kits today, or if you are buying a Meshtastic device, you really need to pay attention to these frequencies, because if you don't do so, you might end up broadcasting in a licensed spectrum. So if you want to just work with raw LoRa, I love that. I actually had a class I was going to do just on CircuitPython with LoRa, and I canceled it because we ran into some shipping problems. But you can program a raw LoRa chip with, provided you have the same host setup, with Arduino, CircuitPython, and probably MicroPython. I haven't tried. I did a whole class on just writing your own encryption, setting the radio settings. The one thing I will note is if you try to use CircuitPython for this, there's a bug where if you try to change any of the radio settings too much, it'll just not be received. I don't know why. So I found that very frustrating, and that's why I like Meshtastic a bit more. But if you did want to do something with Python, this is CircuitPython to send a message. That's as long as it is. Obviously, there's a little bit of import code at the top. I'm just importing some libraries, but that's it. It's not really that complicated to send a message. So what can we do with raw LoRa? Well, my friend Davis made his remote control car. We can broadcast sensor telemetry, control hardware remotely, relay packets. We actually had a speed light, like camera flash, that we set up in Los Angeles. And then we did a video where we walked as far as we could, triggering it remotely until we couldn't anymore. In downtown LA, we did pretty well, almost 2 miles. And if you want to check out the video, it will be live as well. But we have also a video of bad USB attacks. So these devices support native USB. So I can do like USB rubber ducky style attacks over LoRa. So that's pretty cool. I could plug something in and then from a drone come up from over a hill and 15 miles away send a bad USB payload and have it execute on the device. I've actually done this before, so that was pretty cool. So let's go into Meshtastic. We talked about LoRa. Meshtastic adds a layer of encryption, managed flood routing, and convenient apps to LoRa. It allows users to control nodes with Bluetooth, Wi-Fi, or a serial connection, and it's supported on iOS, Android, macOS, and Windows native applications. You can connect it via a Chrome browser, which is honestly the most powerful feature, because anytime you have a Chrome browser unfortunately not on a mobile device, you can use web serial, which means you can flash it and communicate and configure it all through a web browser. No command line, anything. It also encrypts packets and it removes the headaches of matching radio settings. I will explain later, but basically if you have one small part of the LoRa radio settings different, nobody else can hear you. And that's very frustrating when you're trying to just use a LoRa radio raw. So a mesh network uses a variety of different nodes with different roles to build ad hoc networks on the fly. It basically means like me flying in an airplane with my node in the window and people driving around with client nodes in their cars, and then routers up on hills are all combining and routing packets to each other, creating temporary routes as are available. And it builds these routes kind of on broadcast. It sends something out, and whichever devices are furthest away that can respond back and repeat the message will then broadcast it to the rest of the mesh. Managed flood routing is my favorite part of Meshtastic, and I can't really take up too much time to talk about it, but I want to so bad, you guys. So in Wi-Fi, there's this thing called carrier sense collision avoidance, and it's basically, or carrier sense multiple access. And it basically means that Wi-Fi radios and other radios have to like wait a certain amount of time before transmitting to avoid collisions. And there's different rules for how long you have to wait, but there's some cool Wi-Fi attacks you can do by modifying that. So it's interesting that Meshtastic basically uses managed flood routing to prevent just messages flooding the whole network. So if you think about it, if you send a message and then 2 nodes receive it and rebroadcast it, and that just keeps scaling, suddenly you have a huge flood of traffic that makes it so like the network is unusable. So they solve that problem in a really interesting way. So in Meshtastic, packets have the best chance of being retransmitted by a really far away router, or a router that somebody has designated, or a node that somebody has designated as a router. So if someone says this is a router, it's going to be in a super important area, it'll get a shorter like time that it has to wait before rebroadcasting than a node that's closer or in a different role. So theoretically, anyway, that means that the furthest node away and also a node that somebody has designated as a router will have the best chance of retransmitting a packet. And once it does that, all the other nodes shut up. So the idea is like you place routers strategically, you rely on the fact that the furthest router or the furthest node away is going to receive the signal and retransmit it first, and that is usually enough to reduce the amount of traffic on the network along with a couple other mechanisms. So I really wish I could talk more about it, but this is in their own words, this kind of explains the way that it works. But basically, the amount of random backoff time that a packet, that a node waits before retransmitting is based on the signal strength, how far away it is, and the role that it's been given. That's, I guess, if I had to condense it, which I do. And you can read this later on the slides. I wish I could talk more about it. All right, so what kinds of devices can you use? Well, there are a list of usual suspects here. I have the Heltec V3, my first node, a great building block. I have the Lily T-Beam, which I recently destroyed off the top of my car. I have the Whiz Block, which is the preferred node for ultra-low power and industrial applications. I have this thing, which is not as nice as it seems. I don't want to say anything bad, but I've never had anyone who's owned one of these say anything nice about it. But in theory, you'd be able to use it as like a little BlackBerry that like runs Meshtastic. I've just heard that the firmware is not super complete, and if you make the firmware and you're here, I'm sorry. And then, of course, we have the two nodes that we've created. One of them, this is our main thing that we're making to teach people about both cybersecurity and Meshtastic, and then the second one is specific for the conference. So let's talk about encryption. Encryption by default in Meshtastic operates on the channel level. So if you read messages on that channel, like if you're passing messages between other nodes that are on the same encryption settings, they can read everything, for the most part, by default. So nodes that are retransmitting direct messages between nodes that can see the contents of that message if they are sharing the same channel key. And again, I'm an enthusiast. I'm not on the Meshtastic team. I've been a user of this. So if you want to correct me, then you can. But in general, what that means is that if somebody is routing your packets, they can see the contents of those packets unless you create a separate encryption key. So by default, on the long fast channel, that means that if you're sending a DM, it is not a PM, if you know what I mean. So it's not private, basically that's what I mean. It means that anybody who's intercepting it or routing that packet, if they're on the same channel, the same encryption key can see what you're saying. That surprised me. I didn't know that. And I found that out because I turned on my location on this thing, took it on a flight, and then I accidentally publicly mapped my flight path. So, public key encryption has recently been introduced into Meshtastic. It makes it so that you can exchange keys and do real encryption between users. That turns a DM into a PM. So now that this has been implemented, if you see other users that have a lock icon, you can exchange messages using a public-private key relationship. And this is relatively new. It was only implemented, I think, like 4 or 5 months ago. I don't totally remember, but because it's kind of new, users are already spoofing the little lock icon in their username to make people think that it's encrypted on like an older device, which I think is super clever and funny. But that's basically when you're in the app and you see a user with a lock sign, that means that they're using the newer version of Meshtastic, which includes encryption. But prior to that, or on the public channel, you just need to be aware of when things are encrypted and when they're not. So cheat sheet. Nodes communicating on long fast with the default encryption. All nodes can see your messages on that channel. Nodes communicating on long fast, but with a different changed encryption key. Well, only people with that encryption key on the same long fast channel will be able to read it. So that's a bit better. And the nodes who have exchanged encryption keys communicating via DMs should only be able to be read by each other. So I kind of thought it would be like a little bit, I thought everything would be like super locked down. So when I saw that other nodes were reporting like my trace routes and other things back to MQTT servers, which were getting uploaded to maps, I was like, oh, this is actually a bit more public than I thought. So how do we install this? Well, we can do it via a web flasher. We can do it via esptool.py, which I'm very comfortable with, and we can also compile it and flash it with Platform IO. I've never been able to get it to compile on Platform IO. So I reached out to the Meshtastic team, and they've been wonderful about helping us with getting some of the hardware set up. But if you're comfortable with Platform IO, it's really easy, actually, to configure some specific settings, customize this, flash it, and then get it in a state that other people can flash it too. Your options for interfacing with it are a mobile and desktop app and the web interface. And you can see some examples here. You can see me using the web client here, which is very nicely laid out. The Mac native application actually automatically graphs your sensor telemetry data, which is very pretty and nice. I didn't ask for it, but I like it. And then the Android application, I think, is by far the most like capable way of configuring the radio. It really has a lot of like options and settings. It's the one that I prefer. But you can also configure it via command line. I had several people demand to do that today. So if you want to do it via command line, I'll get into that as well. So you just got a new Meshtastic node. You plug it in. It doesn't work. What do you need to do to get it working? Well, first you need to select the region that you're in to allow for radio transmission. So if you don't do that, then it will not transmit because it doesn't want to get you in trouble, which is nice of it. Next, you need to select the same radio settings as the people you want to speak to. So you'll select one of the radio profiles. If you want to add encryption, you can add an encryption key. And then last, you need to add an antenna to avoid burning out the radio by trying to transmit without one. I didn't know about that for my first 2 workshops, but I got lucky. So Meshtastic radio LoRa profiles are designed to prevent that problem I mentioned earlier, where I said it was really easy to mess this up by having one little detail wrong. Meshtastic decided to create profiles for basically use cases and make it easy for people to select the same profile and be on the same page with communication. The trade-off here is between data rate, obviously, and the ability to receive it very far. So we are going between 21 kilobytes per second all the way to 0.09. And 0.09 is very long range and slow. And also, we're taking a trade-off when it comes to speed of transmission. So turbo means we're transmitting very, very, very quickly, and then slow is going to possibly take several seconds to transmit. You get a bunch of nodes all talking on slow, and you're also looking at unintentionally disabling the network by creating too much traffic and basically taking up all the transmission bandwidth or link budget. So when you select a device role, it has real implications. And this was very confusing to me at first. So I'm going to go through relatively quickly the various roles that you would want to use with a Meshtastic node. And I'll start with the ones that I think are the best. The client is kind of the most tried and true basic Meshtastic node. It'll show up on the network. It'll route packets for you. It doesn't get the best priority because it assumes maybe it's not in a great place, but it's tightly synced to your phone or device, and it's a great client device. It's your phone's buddy. It's its router. It connects over Bluetooth and just sends you notifications when you get messages, kind of takes care of all of that. The next is client mute. If you want to, you can make it so that the client doesn't route anybody else's packets. It's just a receiver. It'll send still if you send messages from it, but it's not going to waste any of its time routing other people's packets. It's not a router anymore. So because of that, it will save power. And you can go even further and do a client hidden and then have it not appear on the network at all. Next up, we have a tracker. This is if you have a GPS connected and you want to do like a GPS tracking of a device or an object. Lost and found is very similar. And then sensor is one of the more used ones. I would say client and sensor are the first two that you should probably try out. When you turn on sensor, it will start sending telemetry data from whatever sensors you have connected, and it does a really great job of this. TAC is the military thing I told you about with map sharing from before. Repeater is, I believe, not really recommended by the Meshtastic team anymore. Instead, they kind of prefer routers. But routers are infrastructure nodes that are assumed to be in really, really great positions. And if you set your node to a router, it will instantly stop working with Bluetooth over your phone. And you'll probably flash it a couple of times thinking it's broken. So these are the implications of picking any one of these settings. And you can see if you pick a router, it turns off the Bluetooth and the Wi-Fi because it assumes you want to like save power or that you're doing other things. And this was very confusing to me. So this is very helpful to understand what you're choosing when you're selecting a device role. And you can find all of this documentation also on the meshtastic.org website. They're very, very thoroughly documented. All right, so adding temperature sensors and hardware is super easy. On this Nibble, we broke out I2C and I think SPY, maybe UART, I think SPY, so that you could add additional GPS sensors and then also like I2C. So I2C lets you chain a whole bunch of sensors if you wanted to add like, I don't know, like 5 of them sensing various things, and they should all be able to be recognized provided they're supported by Meshtastic. You just kind of plug them in, it recognizes them, and these are a handful of the ones that are currently supported. You can see we have everything from body temperature, heart rate, oxygen saturation, temperature, barometric pressure. There's a lot, and there's also the support for like very simple like analog signals, like a passive infrared sensor or a millimeter like wave radar presence sensor. Provided it just gives you an up signal when it detects something, you can plug that in and it just works. It's very, very easy. I decided to test this by having it broadcast the message toilet cam alert every time I walked past a radar sensor, and I forgot to change the encryption key, so I blasted my local network with toilet cam alerts for a good 2 days before I realized what I was doing. So when you're testing this stuff, just make sure that you are broadcasting perhaps on your own encryption key if you're really generating a lot of notifications. So also supported, we have UART devices like GPS, spy devices like another screen or other sensors, analog out devices for presence, notification LEDs, and NeoPixel strips. So you can actually have like mood lighting that you're controlling with Meshtastic. So let's talk about modules. Modules are what give Meshtastic special abilities and let you run specific things. Ambient lighting is what I was just talking about, a strip of NeoPixels. Audio gives you the ability to have like notifications when you get a message, so adding a buzzer or a speaker. Canned messages lets you send default message, like pre-written messages using a combination of buttons on a device with maybe only 2 buttons. And then detection sensor is how I was spamming out those alerts all over Los Angeles. You can put just a simple analog up sensor that just triggers a pin as soon as it detects something, and this will send whatever message that you predefine to the entire meshnet. We have MQTT, so if you want to take data and upload it to the internet, I like to use Adafruit IO. You can point the data there, and it will basically forward things from a mesh node over the internet, over Wi-Fi, to another server. So let's say you have one collector, a bunch of sensors around it. It can take all that sensor information, send it to a collector node, and upload it to MQTT. We have neighbor information, which is, as far as I can tell, doesn't work, so I'm going to skip it. And then we have the one that's not super well documented, but fascinates me, the PAX counter. So you can use the Wi-Fi and the Bluetooth radio to detect how many Wi-Fi and Bluetooth devices are around you and get a general number for how many people are in the area. So it's kind of like crowd monitoring, and it's supposed to send you telemetry data of how many wireless devices are nearby. So theoretically, you could detect how big of a crowd is in a certain area. We also have the range test module, which puts out an automated signal and generates a CSV file that shows you where you're getting reception. So if you add a GPS unit, then it's actually going to create a map and show you exactly in the CSV file where you are getting reception. We have remote hardware, so you can trigger something to turn on and off. What that is up to you. And then we have a serial module for doing debugging over a serial port. Store and forward is also really interesting. So if I send you a message and you're offline, it doesn't go anywhere after a certain number of retransmission attempts. If you enable store and forward, it will actually store a certain number of other people's messages, or your messages if you want, and then forward them when the node comes back online, kind of adding a nice little feature. We also have telemetry, which is sending sensor information, and traceroute, which will tell you the complete network path between you and another node. So for advanced use, you can also remotely administer them across a network. So you can send LoRa packets to a node that you want to remotely control, provided you set it up first. You have to set up a custom channel, and you need to exchange, I think it's private keys. With the node that you want to be allowed to control it. So it's a little bit of a setup process, but you can do some of these advanced things and basically put up a node in a place that's impossible to reach again. You can also do Python remote control. So I've been setting up a lot of these using a Python script that I write using the Meshtastic Python library. It's pretty well supported, and if you like Python, you can also get into some interesting scripting. So every time you discover a node, for example, automatically doing a trace route and beginning to visualize and map critical nodes in a mesh network, that's something that you can do with Python and you can do with programmatic control of Meshtastic nodes. I also like to do bash scripting, so I've taken the Meshtastic command line Python script and also just written a couple configuration scripts I use to push configuration settings to new nodes. So I'll flash it, I'll plug this in, I'll run the bash script, it pushes my configuration settings, and I have the screen oriented the right way and the correct region set up. Now, there's a number of different ways you can use mesh networks. You can do a private mesh where you're just running on your own infrastructure, and that means nobody can really see what's going on there. Or you can also do a semi-private mesh, and this is kind of my preferred option. Semi-private meshes are cool because you can use other people's infrastructure to expand your reach, but with a custom encryption key, they can't see your packets. So it's a way that you can still maintain some real encryption without needing to let other people see exactly what you're up to. Now, regional networks are a really great idea to get involved in. I've been involved in organizing meetups for SoCal Mesh, and that basically reaches all the way from San Diego all the way up to Santa Clarita. It's a huge mesh net, and there's a lot of active participants adding infrastructure every day. If you want to map this, you can check out meshtastic.liamcottle.net. There are several collector nodes all over the place that are forwarding the packets they see to the internet. And I realized this when I saw my flight path. So I had this node, and it was receiving and routing packets as it was in my bag next to the window, and I found that I could actually look it up and see the exact time and location, as well as the trace routes that I was running on the plane. So that was a surprise to me, and I didn't realize that basically if you're broadcasting location data, this is not just going into the wind. It's being recorded probably by a node nearby. So you should assume that your activities on Meshtastic when you are broadcasting things, or even when people are doing trace routes and finding out what nodes might be geographically near you, there is the potential to leak your location, even if you're trying to be relatively anonymous. So that was really interesting to me, the ability to track nodes, the ability to look these up, because so many people are now running collectors. I didn't know that. So a man in the middle position also was kind of interesting. I was able to see these collectors can see all of the trace routes I was doing, and even the hops on that trace route. So it had a list of the nodes that it went through on the way back. So that was more information than I thought a third party would be able to get from Meshtastic. And last up, I kind of want to talk about accidental malicious configurations. I kind of hinted to this when I talked about setting really long transmission times. So it basically broadcasts for several seconds. If you have like several nodes all broadcasting on a channel that people are trying to use, and they're all sending the B-movie script continuously over and over and over, you're going to run out of bandwidth, and you're not going to be able to use that frequency anymore because you're just going to max it out. So it's very easy to accidentally, at a conference like this, bring 300 nodes online that are designed for long range and are using the long range settings and broadcasting very slowly. So as a result, it might just not work. And that's where you start to see failures at some of these conferences where a lot of nodes all come online. You can also accidentally set your device as a router and put it in a terrible location, and it will create a sinkhole because it will be the first one to respond to that, and it will basically prevent any other mesh node nearby from responding first, even if it's in a better position to relay it. So you can accidentally create sinkholes if you are not careful with your Meshtastic settings. So I think that's almost all my time. If you want to try this for yourself, I have 2 more classes. We're going to be doing one tomorrow, and tonight is a soldering class. If you've never soldered before, don't worry, we'll help you. But the idea is we're going to build our own Meshtastic nodes. We're going to get them set up and also explore a couple ways we can expand them into temperature sensors and other things. And unfortunately, the microcontroller for these boards comes tomorrow, but we spent a lot of time on them. So if you want to check them out, you can come by our booth. And if you want to support our project, we can either mail them or you can pick them up tomorrow if you'll still be there. Thank you also to my team who helped make this happen. We have an incredible amount of artists and hardware people who have done an amazing job. We have a former Mythbuster on our team, and also some really incredible people that have been traveling with me since the Nullbyte channel. So I just want to give a shout out to all the people who came together to make the hardware possible and this presentation possible as well. And if you want to check out more of my stuff, on ready.io, that's my team, we have a lot more of these boards that we've chosen specific things to teach about. We go to a lot of conferences, and if you want to see my personal work, you can always go to www.hack.gay. Thank you.
So thank you very much, Cody, for your amazing talk and for creatively tracking your flight. I hope you all are excited to build your own nodes and try Meshtastic for your own. Are there questions? Yes, there are. On microphone number 1.
Hi, so first of all, great talk. I really enjoyed it. At work we have a project that I thought we could control with a Meshtastic network. And my question is there a way to send just strings of text over serial or I2C that gets sent through Meshtastic through a specific channel that only that channel gets forwarded to I2C?
Yes. So Python control lets you do a lot of custom configurations. And in particular, one of my friends just wrote a Python wrapper that receives a message, parses it, and sends an automatic reply and response. So because you can have programmatic control of receiving a message, sending it, you can basically control, like from a Raspberry Pi or something, a Meshtastic node in a completely programmatic way. So if you have a specific way you would do it, and then you set up the channels so that you're only able to be received and understood by nodes that you trust, then you should absolutely be able to do that.
Thank you.
All right. Microphone number 4, please.
Yeah, thanks for the talk. I have the question regarding the LoRa ecosystem because the chip is still proprietary and you can emulate this, but there's the new sub-gigahertz Wi-Fi. Do you know of any plans that they will port it to that too?
So I've heard of some different protocols that are expanding like the LoRa protocol specifically to other types of radios. So the chirping like up and down thing doesn't just need to be on this unlicensed spectrum. It can also be applied to like Wi-Fi. And one project in particular I heard that is doing this, I think is Reticulum, that a lot of people have mentioned to me. So there's like, it's interesting that like this kind of chirping spread spectrum thing is very useful on LoRa, but also it seems like it can be adopted to other types of radios. And like other people are kind of taking the Meshtastic like schema of sending messages and trying to apply it to other things and make it a little bit less proprietary.
Thank you.
All right, microphone number 6, please.
Yes, thank you for the talk. You have talked about the maximum range of Meshtastic. So what was the longest connection you have made at C3 via Meshtastic?
I actually have not been broadcasting my location, so I haven't gotten a positive read on that yet. So unfortunately, I haven't yet been able to range that. But I think like ground to ground, I average about 60 kilometers when I'm in the United States. Slightly different range, but I've just been teaching workshops all the time, so I haven't been able to measure yet.
All right, thank you.
Yeah.
Okay, microphone number 1, please.
First of all, thank you for the talk. One quick thing, you talk about many different ways to build a module or using many different host chips. Have you ever thought about using the STM32WL line of chips because it integrates the Semtech radio inside the silicon? They have a contract which works rather well, and they have just an internal SPI bridge, which allows us to use a internal, rather highly efficient, low-clocked ARM M4 core, which just sits on silicon. And you have like BGA packages around 3 times 3 millimeters, which have the whole like physical stack for LoRa and everything on board. Have you already tried those?
I haven't. So I have a lot of experience with Espressif microcontrollers. I've been working with them for the last 5 years. So the fact that they were supported, I just gravitated towards what I knew. I know ESP tool, like, you know, it's a pretty easy way of flashing. But I am really excited about things like this because it means that you can do a lot of the same Meshtastic stuff. They do require, I forgot to mention that they require a SPI connection. And that I didn't realize. I bought a lot of the nicer like LoRa chips that are on a breakout board that's UART. And unfortunately, UART tries to be too smart. It tries to do LoRaWAN, which is different from Meshtastic. And because LoRaWAN does some things that Meshtastic isn't compatible with, it means that all the chips that I bought that were upgraded are garbage. So SPI connections are good, high integration is good, and I'm really excited to explore more of these more capable chips because Espressif is what I started with, but obviously like the Nordic Semiconductor line of like Meshtastic nodes, like or rather the line of Meshtastic nodes supported by Nordic Semiconductor chips are really powerful. They have so much stuff integrated. I just am less experienced with them.
Okay, thank you.
Yeah.
All right. Thank you very much again for your talk, and I wish all of you happy hacking, and again, a loud applause.
Thank you.